Hello students, welcome to Educate. In the last class, we have discussed about the solubility of gas in a liquid. Now, we will discuss about the numericals asked based on the solubility of gas in a liquid. And you know that the solubility of gas in a liquid studied by Henry's law. Let's see. Numerical question, this one, 1.6 question. Let's see how to solve this question. Very easy question here it is. It is H2S, a toxic gas with rotten-like smell, is used for the quantity analysis if the solubility of H2S is this much. This much molar here. Solubility is here given in terms of molality. So, what you will do? First of all, you will have to convert this concentration, that is molality, into mole fraction. Let's see how to convert. It is molality is 0.195 molal. That means what's the meaning of molality? That is how much number of moles of solute is present in 1 kg of solvent. Here solute is H2S and solvent is water. So let's see, molality is 0.195. That means in 1 kg water, number of moles of H2S will be how much? 0.195. Okay. Now 1 kg water it is. So convert them into mole. So number of moles of water. That will be equal to how much? 1 kg means 1000 gram and upon molecular weight, that is 18 gram per mole. That is, when you will solve this one, it will come 55.55. That is mole. How? Because gram will cancel out, mole will go in the numerator and that become mole inverse will go in the numerator and that become mole. So mole fraction of H2S will be how much? Number of moles of H2S is 0.195 and that upon number of moles of solute 0.195. That much mole upon 0.195 mole plus 55.55 mole. That is, so 55.55 plus 0.195. You may take care to calculate fast as 0.2. So that will be equal to 0.195 upon 55.7. Okay guys, mole fraction will be that much. Okay, very easy it is to calculate the number of moles of H2S. First of all, you will have to find out the number of moles of water. And how? Because 1 kg water, H2S, 0.195 mole of H2S has been dissolved in 1 kg water. 1 kg water means 1000 gram water. So, how to calculate number of moles? So, that will be 1000 gram upon molecular weight of water, that is 18. So, that much 55.55. Mole fraction of H2S, so number of moles of H2S, that upon number of moles of H2S plus number of moles of water. That much came. Now, it is what is it asking? Calculate Henry's law constant. So, you know already partial pressure of any gas, that will equal to Henry's law KH into mole fraction of that gas. So, partial here it is at STP. watch out here. STP means standard temperature pressure. Standard temperature pressure. And you know the standard temperature pressure is 273 Kelvin, and that is standard temperature is 273.15 Kelvin, and standard pressure is 1 atm. So let's see here. So KH you will have to find out. So KH, that will equal to 1 atm, that upon mole fraction of water you have calculated 0.195 upon 55.7. Calculate this one, you will get Henry's law constant. Okay guys, very easy question it is. Now let's see this question. Henry's law constant for CO2 in water is this much. Henry's law constant has been given. Calculate the quantity of CO2 in 500 milliliter of soda water. 5 milliliter of soda water means here the mass of soda water will be 500 gram and pressure is 2.5 atm. So like that, here only slightly modified question it is. This question is only slightly modified. So this question I hope you can solve very easily. Even though if anyone could not solve this question, may comment in the comment box. Okay, then after I shall solve. That was about Henry's law. Recall that Henry's law is applicable for the solubility of gas in a liquid. Now we will discuss about the solubility of liquid in a liquid. Okay, so solubility of liquid in a liquid we have to discuss. First one is vapor pressure. As the name indicates, vapor pressure. So you may imagine vapor pressure means pressure of vapor. That means what is that vapor pressure? This is a liquid here, whatever be that liquid here, that may be pure liquid or the solution also. So this is a liquid. The liquid particles undergo in vapor phase. That's maybe at room temperature or if you supply heat energy. So these liquid particles undergo in vapor phase, and then after it exerts the pressure over the surface of liquid. Liquid particles undergo in vapor phase, and that vapor exerts the pressure over the surface of liquid. So that pressure is called vapor pressure. Vapor pressure. In the 12th board examination, a question asked, define, and one of them is vapor pressure. For IIT Main, Advanced, NEET or the CUET, question, you will have to know what is vapor pressure is. Okay, so what is vapor pressure for 12th board examination? Watch out, very easy. Watch out here very seriously. Vapor pressure. So we tell the pressure exerted by the vapors of a liquid. This vapor is exerting the pressure. So that is the pressure exerted by the vapors of a liquid at the surface of that liquid. So vapor pressure is defined as vapor pressure exerted by the vapors of a liquid at the surface of that liquid. So vapor pressure is the pressure exerted by the vapors of a liquid at the surface of that liquid. That is vapor pressure. Okay guys, hope this one will be clear for you. Now let's see about the Raoult's law. What is Raoult's law? As the Henry's law describe about the solubility of gas in a liquid. Like that, the Raoult's law describe about the solubility of liquid in a liquid. The Raoult's law describe about the solubility of liquid in a liquid. Okay, so what is this one here? What the Raoult's law have stated? That have stated the Raoult's law, this one stated that the solubility of gas in a liquid, the solubility of gas in a liquid will be directly proportional to the vapor pressure of that gas over the surface of liquid. In the same way, Raoult's law have also stated the solubility of a liquid in a liquid. The solubility of liquid in a liquid will be directly proportional to vapor pressure of that liquid. Raoult's law stated that the solubility of liquid in a liquid will be directly proportional to vapor pressure of that liquid. Same as Henry's law has stated. So let's see here in the books that has been written the definition also. For a solution of volatile liquids, watch out this one, which have been in the, your NCERT book. Watch out this one. The solubility of a liquid in a liquid is directly proportional to the vapor pressure of each component of the solution. This one. Same stated here. Either you may write the definition given in the NCERT book, or you may also write the solubility of liquid in a liquid will be directly proportional to the vapor pressure of that liquid. Okay guys, that is here. Or listen, so that means here the partial vapor pressure of, that means vapor pressure, partial vapor pressure of liquid 1. Listen, suppose here is a container. In this case, there is two liquid. One is liquid A, another one is liquid B, or liquid 1 and liquid 2. Here is about, it has been assumed the liquid 1 and liquid 2. So liquid 1 will undergo in the vapor phase, liquid 2 will also undergo in the vapor phase. So the partial vapor pressure of liquid 1, that will be directly proportional to the mole fraction of liquid 1 in the solution. Keep in the mind, guys, this one is too much important here, and watch out this one sincerely. It is here the partial vapor pressure of liquid 1 is directly proportional to the vapor pressure of liquid 1. The partial vapor pressure of liquid 1 is directly proportional to the mole fraction of that liquid in the solution. Here chi1 is the mole fraction of liquid 1 inside the solution. So remove the proportional sign, so P1 will come to this one. I think no problem here. Same as P2 will be P degree 2 chi2. What is here P degree 1 and what is P degree 2? Suppose if there will be only pure liquid, suppose liquid 1 here. So mole fraction of liquid 1 will be 1. So what the pressure exerted here, that will be in the pure state. So this will be P degree 1. There is liquid 1 only. So that means liquid 1 is in pure state. So the pressure, vapor pressure of that liquid during this pure state is called vapor pressure P degree 1. Vapor pressure in pure state. So P degree 1 will be equal to, when chi1 will be 1, so P1 will be P degree 1. Okay. So In the same way, P2 will be P degree 2 chi 2. And total vapor pressure, addition of both of them. If here, this liquid here, the vapor pressure of liquid 1 is P1 and the vapor pressure of liquid 2 is P2. So total vapor pressure will be addition of both of them. So P total will be P1 plus P2. Now P1, the value of P1 has been putted, that is P degree 1 chi 1, and P2 has been given P degree 2 chi 2. So now chi 1 will be equal to, because chi 1 plus chi 2, it is a binary solution. For binary solution, you have studied that chi 1 plus chi 2 will be equal to 1. So chi 1 will be equal to 1 minus chi 2. So that has been put on the place of chi 1. So that will be 1 minus chi 2 P degree 1 plus chi 2 plus P degree 2. Now solve this one. P degree 1 will multiply by 1. So P degree 1 plus P minus P degree 1 has been multiplied by chi 2. So P degree 1 chi 2. Same way, after solving that, this will become P degree, this value, P degree 1 plus P degree 2 minus P degree 1 into chi 2. Okay guys, for 12th board examination, if you will mug up this one, if you have not understood, and I hope you have understood, but even though, if you have in the examination, you simply put the formula here and get the result. A numerical type question asked in the 12th board examination, question will not ask derive this equation. Question will not ask. As in the physics examination, in the subject of physics, there will be few questions related to derivation in the chemistry. That's usually not asked. So this one you will have to keep in the mind. Now let's see. It goes on the graph here. What about the graph? It is the summation of two graphs. Here in one graph here from left to right when you go, chi 1 is 1. That means liquid 1 is in pure state. Like here, suppose this is here. So liquid 1, there is liquid 1, and in this container there is liquid 2. Now when you add liquid 2 in liquid 1, what happened? The mole fraction of liquid 1 will decrease. So chi 1 here is 1. So when you have added liquid 2 in liquid 1, the mole fraction of liquid 1 has been decreased. So as you move across the period, initially here the mole fraction of liquid 2 is 0. At this state, the mole fraction of liquid 1 will be 1 and the mole fraction of liquid 2 will be 0. When you add liquid 2 in liquid 1, the mole fraction of liquid 1 will decrease and that of liquid 2 will increase. So in this graph from left to right, as you move across here from left to right, the mole fraction of liquid 1 will decrease and liquid 2 will increase. There will be a state that the amount of liquid 2 will be too much than that of liquid 1. So mole fraction of liquid 2 will be nearly equal to 1. When you will add a large amount of liquid 2 in liquid 1, then the mole fraction of liquid 1 will be nearly equal to 0 and the mole fraction of liquid 2 will be approximately 1. So at this state, the mole fraction of liquid 1 is 0 and the mole fraction of liquid 2 is 1. So what happened? As you will increase here, initially the vapor pressure of liquid 1 was maximum, that is P degree 1. P degree 1 is the vapor pressure of liquid 1 in pure state, or that is also the maximum vapor pressure the maximum vapor pressure of liquid 1, that is P degree 1. In the same way, P degree 2 will be the vapor pressure of liquid 2 in pure state, or that may be also stated as the maximum vapor pressure of liquid 2. P degree 2 will be the vapor pressure of liquid 2 in pure state, or the maximum vapor pressure of liquid 2. Okay guys, now let's see. So here at this point, chi 1 nearly 0 and chi 2 1. So here the vapor pressure of liquid 1 will be in here 0. Chi 1 is 0, so vapor pressure of liquid 1 will be here 0, and the vapor pressure of liquid 2 will be maximum, or that will be in pure state. So here that will be, it is P degree 2. Why here P degree 2? Because chi 2 is 1. Chi 2 is 1, so the vapor pressure of liquid 2 will be maximum. Now in the same way, this is when you proceed from right to left. When you will proceed from right to left, the vapor pressure of liquid 1 will increase, and that of the mole fraction of liquid 2 will decrease. At this state, the vapor pressure mole fraction of liquid 1 is 1, and the mole fraction of liquid 2 is 0. So the partial vapor pressure of liquid 2 will be 0, and the partial vapor pressure of liquid 1 will be maximum. That's why this point is P degree 1. The total vapor pressure is summation of that. So from this point to this point, that is the total vapor pressure. What's the use of this graph? Suppose there is mole fraction of liquid 1 or liquid 2, suppose here is 0.3. The mole fraction of liquid 2 is 0.3. So liquid 1 will be 0.7. It is chi 1. Suppose at this point, the vapor pressure of liquid 1 is 0.3 and that of liquid 2 will be 0.7. So that 0.7 plus 0.3, that will be 1. Now, when you will go on this graph, this one, this is the graph of P2, partial vapor pressure of liquid 2. So, the vapor pressure of liquid 2 when the mole fraction of liquid 2 will be 0.3 and that of liquid that of liquid 2 is 0.3 and that of liquid 2 is 0.7. So it is that much. When you will have to find out the vapor pressure of liquid 1, so go on the graph and find out what is that. When you will have to find out the vapor pressure of P total, so P total goes on the graph and find out. So that is the use of this graph, which has been derived by Raoult's law.